Good afternoon, everyone. We will start the webinar in 2 minutes, and hopefully everyone will be able to connect to their devices. So we start the webinar. Thank you so much, everyone, for taking out a little bit of your time today and being with us in the webinar that is related to the Odeon project that we are implementing in knowledge innovation market. So today we are going to talk about the data science carriers that shape the future. But before going to the content of the webinar, I would like to talk a little bit about Odeon and what's the objective of the project. So Odeon stands for Open Data for European Open Innovation. And this project aims at supporting the growth of clusters and SMEs linked to smart specialization strategy of the areas involved, such as culture and creativity industries, green and blue growth industry. It focuses on supporting public institutions to increase the quantity and quality of open data. And it is a 2-year project which is funded by European Commission, and it received a total funding of 2 million euros, started in 2017. And it is expected to be ended by the end of this year. There are a total of 10 partners involved in this project from 7 countries, including 2 partners from Spain, Knowledge Innovation Market, and Sarga, the government of Aragon. We have got a partner, the Chamber of Commerce of Veneto region as a partner, the Chamber of Commerce and Economy of Montenegro, Croatian Agency for SMEs, Innovation and Investment from Croatia, Technology Park of Ljubljana, and Greek Free Open Source Software Society from Greece, Agency for Sustainable and Agency for Sustainable Mediterranean Cities and Territories from France, and Padova Chamber of Commerce and Industry from Italy, and also region of Crete from Greece. So since today's webinar is actually about data science carriers, I wanted to start with data, and I would like to give a short introduction of what is data and how data can be transformed later on to information, knowledge, and wisdom, and how companies use data. And then go to the demand for professions related to data science. And then at the end, we will conclude the webinar, and we will have 10 minutes or 15 minutes for time for questions and answers. So data, in fact, is raw facts. Raw facts can be actually numbers, letters, it can be sounds, noises, or graphic images, shapes, or pictures, for example. So it can take the shape of alphanumeric data, audio data, image data, or video data. And a collection of data organized in such a way that they have value behind the facts themselves, since for example, alphabets by themselves, they don't have any meaning. So once we organize alphabets together in a way that they give a meaning behind the just fact, then it is called information. A process is a set of logically interrelated tasks performed to achieve a defined outcome. So here, a process can be actually transforming data to information. And then once we have the information, and then once we start analyzing the information and we create casualties or um, um, the relationship, actually, when we start answering the question of what happened and actually why it happened, when we dig a little bit into the causes of the things that happened, then we actually are transforming the information that we have into knowledge. So knowledge actually is awareness and understanding of a set of information and the ways it can be made useful to support a task. Then I wanted to talk a little bit about the pyramid of data, information, knowledge, wisdom. So as I already mentioned, data is actually raw facts. It can be, an example can be actually these numbers, 1, 9, 2. The numbers themselves, they do not have any meaning. But then once we give a meaning actually to the numbers, for example, south-facing traffic light on corner of Pitt and George Street as turned red, then we are actually transforming the raw data to information. And once we have actually we have given a meaning to the raw fact, and then we put it in a context. For example, the traffic light I'm driving towards has turned red, then we actually transform information to knowledge. But knowledge actually remains knowledge if it is not actually applied. So once we apply the knowledge, then we reach the level which is called wisdom. So here in the example, then wisdom is actually, it is better that I stop the car or I do not cross the red light. So people actually, whenever they cross a red light on a street, then probably they should understand that they're not wise enough, because they know, they have the knowledge of not crossing the street when it is red, then they're crossing. So knowledge is actually only when people apply it. And it also applies to companies as well. So most of the time, lots of companies actually, they gather a lot of data, and maybe in a stage they start transforming that data to information. But then most of the companies, they get stuck in this stage of information, and they face lots of problems of actually transforming information to knowledge, and later on being able to apply that knowledge in their decision making, or actually creating new business models out of that knowledge that they have from the data. Or even they face problems in applying the knowledge in order to kind of increase their market share or gain competitive advantage in the market. So how many types of data, since now we know what is data and how we can transform it to information and knowledge and wisdom, and let's talk about types of data. Basically, there are two types of data. One is quantitative data and another one is qualitative data. Quantitative data is a type of data that's measurable, and it is collected through measuring things that have a fixed reality. And it also has it is close-ended, so there is an interval for that. Qualitative data is actually, most of the time, it's descriptive, and it is collected through observations, field work, or focus groups, or interviews. Recording or filming conversations, and it is in most cases it is actually open-ended. So Then probably you might be wondering, what is big data? Big data nowadays is one of the most trending topics when it comes to new technologies and new terms related to the new technologies. Then we know that big data is considered to be the next fuel for economies, and lots of companies and countries are actually trying to be the pioneers of big data and gather as much data as possible. So what's actually big data? Big data is data that is too large or too complex to be managed using traditional data processing, analysis, and storage techniques. So once, for example, lots of people actually ask me, we have got a lot of data in our company. Can we consider it big? Or is it big data? For example, we are every day we are storing lots of files, or we are actually gathering a lot of data related to our customers and clients. So when we actually can say that our company has big data, then that's why I wanted to talk about the characteristics of big data. Big data is often referred to as having certain attributes known as the 4Vs. 4Vs stands for volume, variety, velocity, and veracity. So let's talk about 4Vs of big data. The first one is volume. We are all pretty familiar with file sizes in kilobyte, megabyte, and gigabyte ranges. When it comes to big data, data files can exceed those numbers by several orders or magnitudes. Data collections are so larger that they require special storage and analysis options. So when we talk about the volume of big data, then it should actually exceeds the normal volume of data that most of us are familiar with, such as kilobyte or megabyte or gigabyte. So if the data that your company is storing is really large, that actually exceeds, I don't know, 500 gigabytes, then probably you can start saying, so one of the attributes of big data probably might be met in this case. But then volume is not the only attribute of big data. The next V that we talked about is actually volume or scale of data. So 90% of today's data has been created in just the last 2 years. And every day we create more than 2.5 quintillion bytes of data, or enough to actually to fill 10 million Blu-ray discs. And 40 zettabytes, which is actually 40 trillion gigabytes of data, will be created by 2020. Which actually can be introduced as an increase of 300 times from 2005, and the equivalent of 5,200 gigabytes of data for every man, woman, and child on Earth. And most companies in the US have over 100 terabytes, which is actually 100,000 gigabytes of data stored. So now we know that the volume or scale of data is also important apart from the first way that we talked about. Sorry. So the second V that we have to take into consideration when it comes to big data is actually variety. Variety is the different forms of data. So the first one was volume. So volume is really important. It should actually exceed the amounts that we are familiar with. So it should be really big. Then the second thing is variety. It should be the data that has been gathered by our companies, or that we are gathering, should have different forms. A good way to visualize the variety of big data available is actually to think of social media sites. When we think about varieties of data, it's helpful actually to also think of it as either structured or unstructured data. Structured data is the kind of data we actually find in a fixed field in a record, file, or spreadsheet. And unstructured data refers to data that doesn't follow a specific format. Think of satellite images, for example, or photographs and videos, or social media data and medical records. Each of them, they have got different actually format, and actually the data that they give to us are different. So the second most important characteristic of big data is variety. You should be able actually to have different actually types of data related to a specific topic. For example, when we talk about marketing, then probably you might not just want to have the contact of the person or maybe the email address or the name or date of birth or gender. Then probably you also want to have actually their preferences, what they buy, and actually where they go, how many times, for example, they shop in a week. Only when we have all these data, not only just the contact or the name of the person, but also the gender, the age, actually the preferences, only that time probably we can say that the second characteristic of big data is actually met. Then the third characteristic of, this is actually an example of how much data and actually how many types of data are gathered in 60 seconds in our lives if we are using most of these social networks. Actually, for example, LinkedIn is gathering more than 120,000 actually new link posts per more than 120 posts per second. Amazon has got more than 203,000 sales per second, or for example, Uber is gathering more than 1,389 Uber rides per second. So you see different types of data or format of data gathered in just 60 seconds of time. So the third characteristic of big data is velocity. Velocity is actually analysis of streaming data. So velocity refers to the frequency of incoming data that must be processed. Think of text messages. Facebook status updates, credit card swipes, or the multitude of sensors in modern cars. And also maybe the stock market, for example, or the stock exchange. And how many transactions do you think are stored per second or per minute through these devices? So velocity is actually how fast we can gather a huge amount of data. When we refer to big data, then actually we should be able to store a lot of data in a really short period of time. The fourth characteristic of big data is veracity. Veracity is actually trustworthiness of data. Then when it comes to trustworthiness of data, then we probably want to actually know from where the data comes. Is it authentic? Is it trustworthy? Is it complete? Or is it is there characteristics of integrity involved or not? So it's important actually to know what kind of data we are storing and from where we get that data. If the origin is trustworthy, then probably later on we will be able to transform it to information and knowledge. So we don't want actually the base of the information that we have is actually false, or it's not correct, or it's not complete. Because if the data that we gather is not complete, or the origin is not trustworthy, or it's not authentic, then information that we get from that data is also not trustworthy. So the fourth characteristic is actually a really important phenomenon of big data. So companies should be aware actually from where they get the data, and is the data trustworthy to be able to later actually transform it to information and knowledge or not. So all these four V's of big data actually gives value to big data, which actually introduces the fifth V, which is value. Big data adds value only if it is big, which means the volume is really huge. If there is variety, which means that the type of data, we have got different types of data, velocity, if we can actually gather or store data really fast, and veracity, which means the quality of the data is good. So now let's talk about careers in data science. The title data scientist is relatively new actually, and is not yet clearly defined. And due to the fact that it lacks specificity, it can sometimes be perceived as an elevated synonym for data analyst. But that's not the case. Actually, the data scientists actually possesses a combination of analytics, machine learning, data mining, and statistical skills in addition to experience with algorithms and coding. Data scientists also have expertise in the following programs such as R, SAS, Python, or for example, MATLAB, SQL. Later on, we will talk about some other programs or softwares that are really common in this area. But since data scientists are actually most of the time confused or is confused by people and they believe that data science is the same as data and analytics, then let's talk what's actually the difference between data science and data analytics. Data science is actually 100% machine learning and 100% it is related to perspective, while data analytics is actually 75% effort is given to descriptive data, and then 50% effort is put in predictive or correlation finding, and only 5% or 50% effort is actually put in only 25% effort is put on predictive causations. And you see that data scientists, most of the time, they put more effort on prescriptive and machine learning, and also forecasting or prediction, while data analytics, they most of the time they put more effort on finding and descriptions and correlations, sometimes maybe also forecasting, but nothing of prescription and machine learning. There are lots of interesting careers actually to explore related to big data. One of them is data scientists. We already discussed with what is data scientist or what is data science. Another one is big data engineer. For example, another career nowadays really on fashion is business analytics specialist. We have got business intelligence or BI engineers. We have got BI specialists or machine learning engineers. We have got data engineers, machine learning scientists, data visualization developers, business intelligence solution architects, and also analytics managers or statisticians. So these are the profiles which are really in mode nowadays, and people and or companies are actually hiring people with these abilities. Then let's talk about data scientists. Who is a data scientist? Data scientist is someone who has some abilities in R, SAS, Python, MATLAB, SQL or SQL. It's actually SQL. Some people they call it SQL, Hive, Pig, or Spark. Their role is actually cleaning, massaging, and organizing big data. And their mindset, most of them are really curious about data wizards or technologies, and they are actually they've got some special skills and talents. For example, they know about distributed computing, predictive modeling, storytelling, and visualizing or visualization. They have skills in math, statistics, and machine learning. These people are actually most of the time hired by companies such as Google, Microsoft, and Adobe, for example. And data analysts, they are people who collect, process, and perform a statistical data analysis. And most of the time, they're intuitive data junkie, but I figure it out mindset, and they have got special skills and talent. They know how to use, for example, Excel or spreadsheet. They're really good in using SQL and NQ or other databases or database systems. They've got special abilities in communication and visualization. Of course, they should be really good in math, statistics, machine learning. And the languages that actually data analysts are using most of the time is R, Python, HTML, JavaScript, C, and C++, and SQL. Data analysts are most of the time, and they are in demand in companies such as IBM, HP, or DHL. The other profile is actually data architect. Data architect are people who are actually creating blueprints for data management systems to integrate, centralize, protect, and maintain data sources. They're kind of ninjas of data science, and the languages that most of the time they use are SQL, XML, Hive, Pig, and Spark. And they also have some special abilities or skills or talents, such as data warehousing solutions, in-depth knowledge of database architecture, extraction, transformation, and load, which is ETL, and spreadsheet and business intelligent tools. And they're really good in data modeling, and they know how to develop systems. Data architects are actually most of the time hired by companies such as Visa, Coca-Cola, or Logitech. Then we have got data engineers, and data engineers are people who most of the time develop, construct, test, and maintain architectures. So they're actually all-purpose everyman, or the person with many hats. And they speak languages, or they actually use languages such as SQL, Hive, Pig, or MATLAB, SAS, SPSS, Python, Java, Ruby, C++, or Perl. And some of the skills and talents that they have is, first of all, they know how to use database systems, again, kind of SQL. Of course, they have, most of the time, they don't need Excel. They use SQL for any thing that they want to perform. They know how to do data modeling and also ETL tools. They know how to use ETL tools, and they know how to develop data APIs or APIs, and also they have talents or skills in data warehousing solutions. So these people are most of the time hired by Spotify, Facebook, or Amazon. Then we have got statisticians, or the people with abilities, again, in math and statistics. So their role is most of the time is collecting, analyzing, and interpreting qualitative as well as quantitative data with statistical theories and methods. their mindset is kind of, they're really logical and enthusiastic, statistic genius people. So of course they should have abilities in math. The language they use most of the time are R, SAS, SPSS, MATLAB, Stata, Python, Perl, IVE, Big, Spark, and SQL. So they know a lot about the statistical theories and methodologies. They know data mining and machine learning. They also have skills in distributed computing, and they know how to build, not only just build and use, and also use database systems. And also they are really good in cloud tools. Then we have got database administrators. They are people that ensure database is available to all relevant users and is performing properly and is being kept safe. So they're actually the masters of disaster prevention. They're the one that protect actually other people from whatever that might or can go wrong with the data. The languages that most of them are using are SQL, Java, Ruby, and on Ruby on Rails, and XML, and also C+ or Python. The skills and talents that they have is actually they have a lot of backup and recovery skills, which means that whenever you lose the data, then they're able actually to recover it for you. They have abilities of data modeling and design, and they also know about distributed computing. They can use database systems. They know about data security, of course, because they're protecting us. And then they also know how to work with enterprise resource planning and business. They also have business knowledge. Then we have got business analysts, which most of the time actually their role is to improve business processes as intermediary between business and IT. And their mindset is actually they're resilient project juggler. So, and the language that most of business analysts use is actually SQL. So they're really good in using SQL. The talents and skills they have is actually they might know how to use basic tools such as Microsoft Office. They know about the data visualization such as Tableau, for example, and they're consciously listening, and they're conscious listeners and also storytellers, and they know about business intelligence or BI, and also they have abilities in data modeling. These people are most of the time hired by companies such as Uber, Dell, Oracle. And then we have got the last profile that we will talk about today is actually data and analytics managers. So their profile is not just data analytics, they're actually they should have abilities of management alongside data analytics. So their role is actually they are managing a team of analysts and data scientists, and they have their mindset is kind of they're also data wizards, cheerleaders. So most of the time they might not know that much about programming or developing data systems or anything, but they're really good in management. The languages they use are SQL, R, SAS, Python, MATLAB, and Java. And the skills and talents they have is actually they know how to use database systems, of course, not developing them, but they know how to use them. They have leadership and project management skills. They have abilities of interpersonal communication. They're good in data mining and predictive modeling. And of course, they are hired by companies such as Coursera, Slack, Motorola Solutions, and others. So now we will talk about supply and demand of data science professionals, actually. So knowing that data and data science is really important nowadays, and companies are demanding workers. So let's see actually what is the demand in is the demand met by the supply of data scientists or not? Our business review actually, it was according to our business review, data science is actually the sexiest job of the 21st century. And we can actually confirm kind of, or we agree with that, with the quote, just by seeing some statistics. And knowing that actually data science is one of the fastest growing careers nowadays. The demand of data science and analytics job was projected to grow by 15% over the next 5 years, which translated to nearly 364,000 new job postings expected nationally by 2020. Oh, sorry. And the fastest growing roles are data scientists and advanced analysts, which are projected to see demand spike by 28% by 2020. We see that most of the time the data science people working in data sciences takes them really few days to find a job. Here, this survey done by IBM in 2017, they found out that it takes 5 days for them to find a job, and the demand for both data scientists and data engineers is actually was projected to grow from 2070 to 2080 to 39%, and the average salary that they actually found out through the survey for a data job advertised was $80,265 with a premium over all BA jobs of $8,736, which is kind of 81% bigger than, or more than any other average payment for other careers. The business need for data science and analytics varies significantly across different industries, and some sectors are embracing data scientists jobs and skills faster than others. The greatest demand for data science jobs is actually in finance and insurance, professional services, and IT. Together, these three industries alone account to around 59%, I would say, of all jobs, job demands. And data science jobs actually factor most prominently in the finance and insurance industry, where they account for 90% of all openings in that sector. So it means that from whatever job openings that we have nowadays in finance, 90% of them are related to data. And the professional service and IT industries follow with 18% and 17% relative demand for data science analytics jobs, respectively. Means that data systems and IT people and IT industries, so they are from whatever that they hire in a year, 18% of them are actually data scientists or people related to data science careers. Let's talk about now about the differences in salaries. So difference in salaries and hiring difficulty also arise across industries. As it can be seen in the table, the finance industries constantly offer higher pay for data science jobs than other industries, and possibly related to those above average salaries. Data science jobs and finance remains open for shorter time periods than the average. We have already seen that on average, data scientist people actually find a job in less than 5 days. And if they are actually if they want to find a job in finance, then even this number of days actually is decreasing rapidly. So it means that people who want to find a job in data science in finance sector, then it's really easy for them to find an open position. By contrast, science related jobs and professional services are consistently harder to fill than in other industries. On average, data science jobs and professional services remain open for around 53 days, which is kind of 8 days longer than overall average for data science analytics. If we talk about technologies, I mean, I already talked about languages and softwares that most of people in that work in data science are using. If we put them on a scale, then we say that most of data analyst jobs require knowledge of SQL or SQL, also Excel, a really good knowledge of using Excel, W, Python, or SAS, PowerPoint, and SQL Serve. So we can see also here Oracle, SPSS, Java, C, Azure from IBM, MySQL, and other softwares that are used predominantly in this sector. The data actually comes from Jafale. He did a survey in 2020 of the technologies that are the softwares or programs that are used mainly by data scientists or people working with data. So basically, this was the presentation. And if you want to work in the sector, which is really growing fast, then probably you want to start working in one of these technologies, and hopefully soon you will find a job, or maybe even if you already have a job and if you want to update your knowledge of data, then probably you want to start working on some of these technologies, or maybe improve your skills, especially in Excel. I know most of people probably know how to use Excel, but then Excel actually gives lots of functionalities that are related to this data science that most of normal people actually are, and they do not use it daily, or even they don't know how to use them. So probably a good thing might be actually to improve our knowledge of Excel if we want to start working in data science later on. Most of the things that we actually use in Excel are really similar to SQL. Of course, SQL is more complex than Excel, but if you don't know how to use Excel properly, then it's really difficult to start with SQL. It's one of the most used technologies when it comes to data professions and careers. If you have any questions, we have got, actually, we finished a little bit earlier than I was expecting. So if you have any questions, please post them. I see that we have got. Yeah, someone is saying if it was okay. Yeah, they're just comments, they're not questions. I think people are hearing some background noise. So if you do not have any questions, then thank you so much for your attention and have a good day.